Hey, Saintsman, we got here lesson 11.3, which is the areas of polygons. This is a tricky lesson, and it's, again, rather formulaic, and I want you guys just to note that for the Chapter 11 test, but not the quiz, um, you'll receive a formula sheet, okay? Okay, and it's going to be for lessons 11.1 through 11.3 that'll be on there. So, some things to note for this. Um, give you some formulas here. We're gonna we've worked with the area of a square before, and that's just the side squared. But I'm gonna just suggest a different formula here for the area of a rhombus and the area of a kite. And if it applies to rhombus, then it also should technically apply to square. So, for the area of the rhombus and the kite, it's gonna have an area that's 1/2 of the diagonals multiplied times each other, or the product of the diagonals. So here's actually the formula in action. Let's draw a rhombus, right? Oh, I'm sorry. Let's draw a kite. That's not a rhombus at all. Let's draw a kite. Remember where the kite is where we have the two adjacent sides that are going to be congruent, okay? And we have these diagonals here that I'm going to sketch out. And outside of there, I'm going to say that this length of this diagonal is 11 feet. And the length of this diagonal that's horizontal is going to be 5 feet. All right? And we're going to find the area. So this will be rather formulaic. Oh, goodness, guys. You know what I need to do? I need to get... Oh, goodness. What's going on? Let's see here. Let's get that going. Get this booted back up. My apologies, guys. Uh-oh. Errors occurred. It's opening another window, but it is not. So give me a moment. Let's open here. Here we go. Okay. So I'm gonna get my calculator fixed in the other area window in just a moment. So this is the area is going to be equal to 1/2 of the diagonals, area, the length of the diagonals. So the product of this number and this number. So in other words, 1/2 of 5 times 11, which is going to give me 55/2 feet, which is correct, which you could also tell me is 27.5 feet, right? 27.5. Okay. Let's now work with a rhombus. Okay. And then I have this length here, right? So I have this diagonal, and then this diagonal. So this one here is going to be 10 millimeters. Then I'm going to have this diagonal here, which is going to be 24 millimeters. Let's find the area. Okay. So its area is going to be, again, I get 1/2 of the product of the diagonals. So it's going to be 24 times 10. Okay, pretty straightforward. But 1/2 of 24 times 10. Let's put in the calculator. All right. Need my calculator back up. Oops, not logarithm, goodness. 24 times 10. And we multiply times 1/2, or in other words, divide by 2, and that's going to be 120. And that's going to be millimeters squared. Did I have the correct square units on the bottom? Yeah, this is feet squared. My apologies, because it's going to be area. Okay, so we have to work in square units. Now, My question for you is, does this formula work for a square? And I'm asking hint. So think of a square with a side of 2 inches. Okay? And I want you guys to try that one out on your own. I want us to think about one more thing here before we move on. We're going to have a pentagon, a regular pentagon, and I'm going to identify some parts to it. Inscribed into a circle. All right? So, here's another shape here. Pentagon. I'm going to see if I can inscribe this well enough. Oops, that didn't work. Let's try again. You guys might have an easier time with this than I do. Gosh, it's going to be even easier is if I actually take off the auto shapes thing and I'm just going to draw a sketchy looking thing and I have to mark it, right? Which is what you guys are probably going to do too. So I'm going to draw my pentagon. And the way that I'm going to make all the sides equal, I'm going to mark them equal. All right, I'm trying my best. So this is now regular pentagon because all the sides are congruent, okay? So let's identify some parts here. Now, for the center of a circle, it's going to be marked right there, okay? Now, if I'm going to draw this line right here in dark black from here to here, this right here is what's going to be called the radius, right? Because this is the radius of the circle. And it's the longest length from the center of that pentagon, of that regular pentagon, to any part of it, right? Which is what happens when you inscribe that into a circle. Now, what you have is a few other features to this that we're going to be interested in. All right. The next one is from the center, perpendicular to the side. This line right here is what is called the apothegm. Now, there were some students who attempted to use this when solving that fire pit problem and had no idea what it is, but it's this right here. The apothegm we're going to denote with letter A. Okay? A few other things. When we have these angles here, can we, and this is where we're going to do a little foreshadowing, figure out what these angle measurements are? Well, this is a regular pentagon, correct? So what we could do is we could take 180 times the number of sides minus 2 and divide by the number of sides to figure out each interior angle measure, which is going to be 180 times 5 minus 2 all over 5, which is, in other words, is going to be, as we check in the calculator, 180 times 5 minus 2 is 3. So 180 times 3, right? And then we're going to divide that number by 5 to get 108. So the 108 is each of these interior angles of the pentagon. What does that mean? That means that this interior angle, which is bisected, okay, by definition here, with that circle through that radius is going to be 54 degrees. Now, guys, you already see where this is going. This is a right triangle. If this is 54 degrees, right, then it means that this angle right here has to be how much? 36 degrees, right? Because those are going to be complementary. So this is all problem solving that we can do. Why is this important? Well, we're going to find the area of all regular polygons. For all polygons, because we can find the area of triangles, right? 1/2 of the base times the height. Find the area of a quadrilateral, which is the side times the side. It's the length times the width, right? When we get to a rectangle. But then we can do the non-rectangles now, right? We can use with the rhombus and the and the kite. Or we can actually even draw diagonals and make triangles that we can find areas for. But how do we even do that for a regular polygon? Well, we can create what we call these composite figures. But now since it's regular, every regular polygon has the same formula for its area, and it's the 1/2 of perimeter times the apothem. Okay, P is perimeter, and A is apothem. Okay, so you guys ready? I'm gonna draw a regular polygon, but I'm not gonna really draw it. I'm gonna let the software do it for me. Boom, now it's perfect. Ha. Okay, so let's pretend like we have here this, like this would be like a diameter, right? It's like this radius squared, or radius squared, the radius times 2 of 30 of radius times 2, which is going to be the diameter. We're going to say this whole entire length is 32. Okay, this is a regular hexagon, so it has 6 sides, and we're going to find the area. Here's how we do it. Do the same formula. A equals 1/2 of P times A. Okay, so let's mark up the rest. Well, let's go ahead and create this line right here. This right angle, it looks like an altitude from that center, and that's my apothem, okay, which I'm going to have to solve for that, which I have enough information. Because think about this. If this is 32, this has to be 16 right here, right? Now, think about what are going to be all of the lengths for all of these angles, or the measurements for all these angles. Well, let's do it for a hexagon. Now, another way you guys could think of this is that I have here all of these angles, right, that I could do. I could do 6 of these from the center. These all these central angles. And if I do that, I could effectively take the 360 if I had that inscribed circle and just divide by 6, which would give me this whole thing is going to be, for example, here 60 degrees, which means if I'm going to do just this part, it's going to be 30 degrees. And this is 60. Now, what's the other way I could do it? Of course, 180 times 6 minus 2 all over 6. Or in other words, 180 times 4 over 6, which I can put that into my calculator, because why do that all that math myself, right? Might as well just use that calculator. Times 4 divided by 6. That is 120. And then if this is all, the whole thing is 120, half of it, it's going to be 60. So I have a 30, 60, 90 triangle. Okay? I have a 30, 60, 90. It means that this right here, this side, right here, this has to be 8. Has to be half, meaning that this apothem has to be 8 rad 3 because it's a 30, 60, 90, right? Because this to here, it's going to be half, and then to this side, we multiply by rad 30. So I have all the information I need now. Because if this is 8, that's half. This entire thing is going to be 16. So it's going to be 1/2 of each side is 16. There's 6 sides, and then the apothem is 8 rad 3. And the calculator will do all the work for us. So 1/2 of 16 times 6, right? Let's do it. 16 times 6 is 96. So 1/2 of 96 times 8 rad 3. Okay? Half of 96. And then we're going to multiply times 8. So 96, half of it. Okay? And then times 8. So 384. So this will be 384 rad 3. And that's units, because we know what they are. And they're going to be squared, and that's it. Now, no pictures allowed, right? This is what's going to be funny. This is where we're going to go with this. Is we have a regular nonagon. It has sides of 6 inches. What's the area? Well, we don't even need a picture, but you know what we're gonna draw here? This is gonna be fun. You know, you're gonna have this whole thing, right? Okay, but I don't even care about all that. I'm gonna care about this bottom part of it, right? Like as if I were to just zoom in to this, right, to that triangle at the bottom, because it's the triangle that I need. Let's go here to this. Doot, doot, doot. And I have from the center down here, and that's my apothem, and I have my right angle. And then I have this radius that's drawn. So the question is, how much is this angle right here? And if I know that angle, then I know this angle, right? Because it's going to be the complement. And I don't even necessarily need to get into that. So how do we figure it out? Well, 180 times 9 minus 2 over 9, right? So 180 times 7 over 9. (180) times 7 divided by 9 is 140. Okay. So that's this whole thing for the nonagon is 140. So it means that this is 70 degrees and this is 20 degrees. Okay. Now it says that the side is 6 inches, right? This whole side is 6, which means that this, because the apothem is that perpendicular bisector, is going to be 3. Okay. I have enough information to figure all this out because now I need to find this apothem and I get to use trig. This is going to be super fun because if I remember, I have this from the angle, right? That we have the tangent from the angle, right? SOHCAHTOA. So from the angle 70, opposite, adjacent, opposite, adjacent. So the apothem is really equal to 3 times the tangent of 70 when I solve. Okay? Going back here, I have 1/2 of the perimeter times the apothem. Well, the perimeter is sides of 6, but there's 9 of them, and the apothem is 3 times the tangent of 70. Okay? So 1/2 of 6 times 9. It's 27. And I'm going to multiply that now by 3, right? For 81. So this was 27 times 3 times the tangent of 70. And then we multiply those coefficients. 3 times 27, we just saw is 81 times the tangent of 70. And then what are we in? Inches. So this is going to be inches squared. And that's your answer. All right. It's all coming together. All this trig is coming back. But we just use the formula, and there's only one formula. Okay. Good luck, Saintsman.